welcome to another physical science lesson. I'm your presenter, Nico Swartz. Today we'll be looking at stoichiometry. Stoichio what? No, it's just quantitative aspects of chemical reactions. Let's have a closer look at what we'll be covering in this particular chapter. Join me on the board, guys. We'll be talking about the mole. We'll also have a look at molecular masses, molar volume, get a better understanding of what is meant by concentration. We'll be talking about empirical formulas and also percentage yield. And there's our word, stoichiometric calculations. Now, all of these concepts we can see in the calculations. So by doing calculations, we should be able to cover all of these aspects. But let's go and have a look at them individually. Let's start off with the mole. Now this mole is not a living organism under the ground. No, it's not that type of mole. It's also not the snitch within an organization. This is a chemistry term that refers to, let's see, it is the SI unit for the amount of substance. In other words, that means 1 mole is the same amount of substance that has the same number of particles as there are atoms in 12 grams of carbon 12. Now, you'll agree with me, this is a lot of words that doesn't make sense, but sometimes using examples makes sense. So, let's have a look. If you've got 12 grams of carbon 12, it's referred to as 1 mole. So what is the 12 grams? The 12 grams is a specific mass, and carbon 12 refers to its molar mass. And that is exactly what we see here. So the number of moles is the mass, the actual given mass of the substance, divided by its molar mass. Now the molar mass, you'll agree with me, we find on the periodic table. So in other words, if we take oxygen, for example, 16 grams of oxygen will be equal to 1 mole. Why? Because we take the given mass, which is 16, divided by the molar mass of oxygen, which is also 16, and that gives us 1. So that says that 1 mole of any amount of substance having the same number of particles as there are in atoms of 12 grams of carbon 12. Let's talk about the molar mass. Now the molar mass is the mass of 1 mole of a substance, and it's important to note that it's measured in gram per mole. So let's quickly take an example of water. What is the molar mass of this molecule of water? We need to consult the periodic table, and you'll find that the atomic mass number of hydrogen is 1.00, but let's just round it off for now. There are 2 hydrogens plus the molar mass of oxygen on the periodic table, 16, there's only one of them. So if we get the answer here, we'll have 18 grams per mole is the molar mass of water. And so too you can work out the molar mass of any other substances. Let's talk quickly about molar volume. Now under the molar volume we've got a law. Remember what's the instruction with laws? We must be able to rewrite the laws. You need to be able to give it word for word according to the examination guidelines. Alright, so we've got here that 1 mole of any gas occupies the same volume at the same temperature and pressure. So, same temperature and pressure is STP. Can you see? STP. Well, the S is actually for standard temperature and pressure, STP. And what is this molar volume? So the molar volume of any gas at STP is 22,4 cubic decimeters, per mole. At standard temperature, 273 Kelvin, and your standard pressure is 1 atmosphere, which is 101,3 kilopascal. So that is molar volume. And Avogadro states that any gas at STP occupies the same volume, which is 22,4 cubic decimeters per mole. Let's talk about concentration. So for concentration, I want to use an example that I think most of us, if not all of us, can relate to. So how many of us likes Oros? I know, I'm a big fan of Oros. Are you? I cannot think of a better drink when it's hot outside and you are thirsty. Now, Oros comes in a bottle of concentrate. Now, just imagine, let's do an imaginary experiment. We add a teaspoon of Oros, the concentrate, into a glass of water. And in another glass, same size, exact same glass, we add 5 teaspoons of Oros into that particular glass of water. Imagine how they would taste. The 1 spoon of Oros compared to the 5 spoons of Oros. So the glass with only 1 spoon would have a very watery taste. It would actually be diluted. That's the correct word to use. Compared to the 5 spoons, which most probably would have a better taste. Perhaps let's add a third one to our equation. What if we invert our ratio? We put a glass of Oros and only add 1 spoon of water. Can you see what am I doing? The concentration changes. So the one that's very sour and not very pleasant to drink is very concentrated. While the one which has very little bit of Oros in just 1 spoon, that would be diluted. So that gives you an idea of what is concentration. Let's put it into perspective. The amount of solute per liter of solution. So the solute refers to our Oros. And the solution we are looking at is specifically our solvent, and that is water. So when we calculate concentration, we do that in mole per liter or mole per cubic decimeter. And we use the equation, the number of mole divided by volume. So C is equal to N divided by V. At this point, let's take a break. Let's go and have a nice cold glass of Oros, come back refreshed, and we tackle specific problems for the section of stoichiometry. Welcome back, guys. I hope you are refreshed and you've got your glass of Oros next to you. Let's go and see some of the other concepts in practice. So we're looking at a particular examination type of question. And let's see if we can answer this question. Join me on the board. So methyl benzoate is a compound used in the manufacturing process of perfumes. It is found in this particular example. We've got a sample of 5,3 to 5 grams. And the sample contains 3,758 grams of carbon, 0,316 grams of hydrogen, and then there is 1,251 grams of oxygen. Can you guess what the question will be? I'm starting to see where we're going with this. Let's determine the empirical formula for methyl benzoate. What is the first thing we need to do? Let's use a table method. Carbon, hydrogen, and oxygen. Let's write down what were those masses that they gave us. So carbon was 3,758. Hydrogen was 0,316. And the oxygen was 1,251. The first thing we need to do is to work out the percentage that these elements make up for our sample. So how are we going to do that? We're going to take the masses provided, and then we're going to divide it by the mass of the sample, and that is 5,325. That's for all of them. 5,325, and this one as well, 5,325. We need to convert them to percentages. All right? So in actual fact, we are calculating the percentage composition. So what percentage does carbon make up of our sample? And the same with hydrogen and the same with oxygen. So if we want to convert that to a percentage, we need to multiply by 100 for each of these. So now we're going to get our percentages, and we'll see that carbon is 70,573. Oxygen is 5,934. Remember, these are percentages. And then oxygen is 23,493. All of them are percentages. Now we need to convert them to number of moles. So maybe let's put in here percentage. That is percentage. And the next thing that we're going to calculate is the number of moles. So number of mole is the mass. So we'll assume that these are now converted to masses. So number of mole is the mass divided by the molar mass. The molar mass of carbon is 12. Remember, you need to use your periodic table. It must be right next to you. 5,934, and that will be divided by 1, because the molar mass of hydrogen is 1. 23,493, and that is divided by the molar mass of oxygen is 16. What are these answers? They will be 5,881 and 5,934. Remember, all of them mole, because we're calculating number of mole. All right, and this one is 1,468, and that's also mole. we're still not done. One last thing we need to do. We're going to divide by the smallest number that we've got there. The smallest number is the 1.468. So all these numbers you divide by 1.468 and you'll find that this answer is about 4,006. The next one is 4,04. And obviously this number divides by itself. It gives you 1. And that gives you an indication that carbon is 4, hydrogen is 4, and oxygen is just 1. Therefore, our empirical formula is carbon 4, hydrogen 4, and just 1 oxygen. Let's see if we can answer the second problem that I've got for us on the board. Let's go and have a look what it's all about. Iron reacts with sulfur to form iron sulfide according to the following balanced equation. This is really important, guys. When you work with stoichiometry, you need to make sure that all the equations are balanced. All right? So if it does not state that it's balanced, rather go and make sure that it is. Okay, so there we see our balanced equation. Why is it so important? Because we need to look at the mole ratios. So 1 mole of iron reacts with 1 mole of sulfur to form 1 mole of iron sulfide. So the mole ratio there, whichever you are working with, is 1:1. Very important. What is the question? Calculate which of the two substances will be used up completely. Ooh, this is something very important. So we're talking about limiting reagents. Now, what is a limiting reagent? That is the reagent or the reactant which causes the reaction to come to a halt. In other words, it's been used up completely and the forward reaction cannot continue any longer. So in this particular question, we need to go find out between iron and sulfur, which one is going to be finished first, and therefore the reaction will come to a stop. So that is what the question is about. How do we do this? Let's have a closer look. Important, it's 20 grams of iron that reacts with 10 grams of sulfur. So let's have a look at iron. We are going to start off by calculating the number of mole of iron. And number of mole is mass over molar mass. Now I put a little r there because it's a relative molecular mass or molar mass. It's the same thing. Is equal to the mass they said for iron was 20. What is the relative molecular mass of iron? It's 56. Remember, you don't need to memorize all these things. It's on the data sheet or it's on your periodic table. And that gives us 0,357. 0,357, and the unit is mole. Let's then also go have a look at sulfur. What is the number of mole of sulfur? Number of mole of sulfur, same equation, mass over relative molecular mass or molar mass. They said it's 10 grams of sulfur, and the molecular mass there is 32. That gives us 0,312. We can actually continue and put a 5 in there. I'm not rounding anything off as yet. Mole. Now, we said the mole ratio is 1:1. And where do we get this again? From the balanced chemical equation. So the mole ratio 1:1. It means 1 mole of iron reacts with 1 mole of sulfur to form 1 mole of iron sulfide. That means the number of moles should be equal. Can we see what's happened here? Are they equal? No, they're not. 0.35, 0.31. Now, because this one is the smallest of them all, or between the two of them, so because sulfur has a smaller number of mole than iron, it is the limiting reagent or the limiting reactant. Let's go for a small break again. We'll come back and we'll look at another problem. See you at the end of the break. Welcome back, guys. Let's have a look at another problem. We're looking at question 3, and let's see, and I know for certain that you'll be able to answer it very easily. Join me on the board. Let's have a closer look. Magnesium burns in air to form magnesium oxide according to the following balanced equation. Remember what I said? We need to make sure our equation is balanced before we start calculating anything. So when the question indicates balanced, we are happy. All right, so we've got 2 magnesiums reacting with 1 molecule of oxygen, and that forms 2 magnesium oxides. And by doing that, we've indicated what is the mole ratio. So the mole ratio between magnesium and oxygen is 2:1. The mole ratio between magnesium and magnesium oxide is 2:2. Let's continue. The question says, if the percentage yield of this reaction is only 80%. This is very important. So if you put this in a test tube to react, the yield of magnesium oxide would only be 80%. So 20% would either go back to form your reactants. All right, we must calculate the mass of magnesium. This is important. We want to calculate what mass of magnesium is needed to burn, to produce 30 grams of magnesium oxide. So we want 30 grams of magnesium oxide. Let's go and start. We've got the first thing covered at least. We've got the mole ratio. What are the compounds or elements that we are looking at? The question is referring to 30 grams of magnesium oxide, and it's asking what mass of magnesium. So we're looking at magnesium and magnesium oxide. That is important because the mole ratio we're then looking at is 2:2, which is actually simplified as 1:1. Very important to keep in mind. Let's start off with this 30 grams that we've been given. Let's go and calculate how many moles are there in 30 grams of magnesium oxide. All right, so the number of moles of magnesium oxide is equal to the mass divided by the molar mass. So the mass they gave us was 30. The molar mass of magnesium oxide is 40. Therefore, that is equal to 0.75, and this is mole. So now we use our mole ratio. Our mole ratio says for every 1 mole of magnesium, it will form 1 mole of magnesium oxide. Therefore, if we know the number of mole of magnesium oxide, we'll know what's the number of mole of magnesium. So, therefore, the number of mole of magnesium will be equal to 0.75 mole. We can, once we've got the number of mole, we can go and calculate what's the mass. The mass of magnesium is equal to the number of mole times by the molar mass. So the number of mole we know is 0.75, and the molar mass of magnesium is 24. Therefore, the mass is 18 grams. 18 grams. So we've determined now, using the mole ratio, what mass of magnesium is required to yield 30 grams of magnesium oxide. Is the 18 our final answer? What do you think? No? Somewhere there's a warning going off. Something is still not right. And you are correct when you're thinking about that 80%. That 80% was very important. Let's go and have a look again at what the question was saying. So, here we highlighted the 80. Let's read again. If the percentage of yield is only 80%, calculate the mass of magnesium that is needed to be burnt to produce 30 grams of magnesium oxide. What we've calculated is how much magnesium is needed to produce 30 grams of magnesium oxide. But the percentage yield is 80. So we need to know if 18 grams is producing 80%, how much do we need to produce 100%? Let's rewrite that quickly. We found 18 grams of magnesium is needed to produce 80% of our yield, which is magnesium oxide. The question now wants to know how many grams, let's call it X, do we need to produce 100%? Now we're going to do a very simple cross multiplication, and we'll have X times 80, which is 80X, is equal to 18 times 100. We need to make X the subject of the formula. X is then 1,800 divided by 80. And we'll find that X is equal to 22.5 grams. So now we can clearly see if you use 18 grams of magnesium, it would produce only 80%. But if we wanted 100%, we need to actually increase that to 22.5 grams. Guys, that is what we have time for in this particular lesson. Thank you so much for joining. I look forward to seeing you in all the other lessons that we will be producing for you. Keep safe and see you again. Bye.